Question 27, 4 marks. The following procedure is proposed to test for the presence of lead-2 and barium ions in water at concentrations of 0.1 moles per liter. 1. Add excess 0.1 moles per liter sodium sulfate solution. If a precipitate is produced, then barium ions are present. Filter any precipitate produced. 3. Add excess 0.1 moles per liter sodium bromide solution to the filtrate. If a precipitate is produced, then lead-2 ions are present. Explain why this procedure gives correct results when only barium ions are present, but not when both barium and lead ions are present. Include one balanced chemical equation in your answer. The best way to answer this is to give a detailed structure of the whole process. So this is what I'm going to do. Let's just write out in chemical equation form what is happening. So the question is saying that you have both the presence of lead aqueous and barium 2 plus aqueous. The procedure goes that excess sodium sulfate was given to the mixture. Barium sulfate is formed. So barium 2 plus aqueous plus SO4 to negative aqueous goes to barium sulfate, solid. The solid was then filtered, and then presumably the filtrate is then just the remaining lead-2 plus. The filtrate was then added with sodium bromide. We can then say lead-2 plus aqueous plus Br minus goes to lead bromide. Now let's have a look at the theory when you are going to determine which of the precipitate actually is formed in the sequence of events. We have a mixture of lead-2 plus ion and barium 2 plus ion. Excess sodium sulfate was added to the mixture. What should we expect in our answer? Well, let's look at the table. We can see that barium 2 plus and lead-2 plus precipitates. You will not be able to distinguish between the two, since lead sulfate and barium sulfate are white solids. This would make the identification invalid. The only way this could make sense is the solution only has one species, which is barium. So then adding the sulfate would just precipitate out that one single item. In the case of lead-2 plus and barium 2 plus, if in the presence of sodium bromide, the theory says that barium bromide is soluble. So barium bromide is aqueous. It will stay in the filtrate. In the case of lead-2 plus, lead bromide gives you a precipitate, and henceforth, if we were to distinguish between the two, then it's now more clear cut. In summary, test 1 is invalid because the addition of sulfate will simply give you both lead sulfate solid and barium sulfate solid. So you won't be able to distinguish between the two. This will only be valid if one species is present in the solution. Test 3 is valid because only lead bromide will be precipitated out, while barium bromide remains as an aqueous solution. Thank you for watching. Please follow and subscribe to this channel for more quality contents. I'll see you next time.